Imagine trying to lift this heavy load with your hands alone. You pull upward, but the load barely moves. Its weight is still acting downward, and your muscles must provide a large upward force. Now slide a strong beam under the same load and support the beam on a pivot. Push down at the long end. The beam rotates about the pivot, and the load rises. The load didn't become lighter. So what changed? The lever changed how the learner's force acted. In physics, a machine is a device that helps us use force more effectively. We can represent the interaction as effort through the machine to the load. On this lever, the effort is the input force applied by the learner. The load is the force the machine must overcome. The fulcrum, or pivot, is the fixed support about which the beam rotates. These are not just labels. Their positions control what the lever can do. A machine may change the magnitude of a force. A smaller effort can produce a larger force effect at the load. It may also change direction. Here, the learner pushes down while the other end of the lever moves up, but there is a trade-off. Watch the ends of the lever. The effort end moves through a greater distance, while the load rises through a smaller distance. In this ideal illustration, a 50-Newton effort moves 0.4 meters, and the 200-Newton load rises 0.1 meters. Input work is 50 times 0.4, or 20 joules. Useful output work is 200 times 0.1, also 20 joules. So the machine has not created energy. It has traded force for distance. In a real machine, friction and deformation mean the input work would be a little greater than the useful output work. We describe the force advantage using mechanical advantage, abbreviated MA. Mechanical advantage equals load divided by effort. The load is the force overcome. The effort is the input force applied. Now try this. If a 50-Newton effort lifts a 200-Newton load, what is the mechanical advantage? Use MA equals load divided by effort. Substitute the values. 200 newtons divided by 50 newtons. The newtons cancel, so mechanical advantage has no unit. 200 divided by 50 equals 4. A mechanical advantage of 4 means that, ideally, the load force is 4 times the effort force. It does not mean 4 times the energy. The larger force effect is matched by the effort moving through a greater distance. Let us verify the model. The effort acts 4 times farther from the fulcrum than the load. So, in this ideal lever, a 50-Newton effort can balance a 200-Newton load. To make the load accelerate upward, the effort moment would need to be slightly greater than the load moment. The distance trade-off and the work calculation agree with the same physical model. A machine connects effort to load. It can change force magnitude, force direction, distance, or speed, but it cannot create energy. Mechanical advantage tells us the load force effect compared with the effort. Machines don't remove work by magic. They help us use force more intelligently.